Hey, welcome back to Math with Patrick. It's March 27th, and we have problem number 86 to solve together from this Daily Epsilon calendar. It's going to be a pretty quick video today. It's just a little bit of arithmetic, or essentially just working through the numbers and figuring out why this number right here is 27. Now, kind of treating it as is with no extra tricks. I just see an order of operations problem. I know that exponents happen before multiplication and division, and then multiplication and division have the same priority, and so you're supposed to do them just left to right, kind of like as you would read in English. So 3 to the power of 4 just means 3 times 3 times 3 times 3, which turns out to be 81. 3 to the power of 5 is another 3 multiplied to that list, and so that turns out to be 243. And then 3 to the power of 6 is yet another times 3, and that totals to 729. Now, just thinking about order of operations, my next step would be to figure out what this number is, but I don't really want to do that. That's going to be a pretty large number. Instead, it might be easier to think about keeping it in exponential form instead of dealing with these large numbers. So I was trying to figure out what this number is, 81 times 243, and that's just a whole bunch of 3's multiplied to each other, right? We have 4 here and then 5 here. So altogether, I have 9 3's all being multiplied, and then I'm going to divide it by 6 3's. And sometimes it might even be helpful to write out this division kind of as a fraction instead. And so here's all 9 of my 3's all being multiplied together first. And then I'm dividing them by multiplying 6 3's altogether. And with fractions like this, you can simplify when you see the same factor on the top and bottom. Basically, if you multiply by 3 and then divide by 3, that's just getting you back to where you started, or it's kind of just like multiplying by 1. Basically, these just don't do anything. So anytime I see a repeated factor on the top and bottom of a fraction, I can just cross them out. So all 6 of these 3's are going to be crossed out with all 6 of those 3's. We don't have a 0 in the bottom. You could imagine doing a times 1 to the beginning of this product. And so we have a 27 over a 1, because 3 times 3 times 3 is 27. So ultimately, we just get 27. And that's today's date. Maybe an exponent rule way to do this is that when you see multiplication in exponents, you can, with the same base, so the same base of 3, and we're multiplying and we have different exponents, this is a good situation where you can just add these two. And as you can see here, it turns out to be a 9. And then when you have the same base and you are dividing two numbers, then you can just subtract the exponents. So this 9 and this 6 subtracted to get 3 cubed, which was hiding right here in my fraction. So whether or not you use exponent rules or whether or not you think about crossing off factors in a fraction, the answer is 27. Even if you decided to multiply it all out and figure out what that really big number is, either way, you're going to get 27 in the end. I just don't recommend actually trying to do the arithmetic with those big numbers because you don't have to. So that's all from me today. Thanks for coming along as always, and I'll see you tomorrow.